Regression analysis for beginners. Predicting the future through data. Think about it. Your friend studies 2 hours and gets 50 marks. Another studies 4 hours and gets 70. Is there a pattern? Can we predict what you will get? Economists don't guess. They use regression analysis. By the end of this video, you'll understand exactly how it works, even if you've never done statistics before. Let's begin. 3 questions. Listen carefully. 1. Does study time affect your exam score? 2. Does price affect how many people buy something? 3. Do higher interest rates slow inflation? All ask the same thing. How does one thing affect another? In every case, we have one factor we want to explain. We call this Y, and one factor driving the change. We call this X. Regression answers, how does X affect Y, and gives us a precise number, not a guess, a real number. X and YX is what we think causes the change. Study hours, price, interest rates. Y is what we want to explain. Exam score, sales, inflation. Want to know if studying helps? X is study hours. Y is exam score. Want to know if price affects demand? X is price. Y is quantity sold. X causes. Y is the result. Regression finds the exact relationship. The core idea. Here's the simplest definition. Regression finds the relationship between two variables and tells us exactly how much Y changes when X increases by 1 unit. That's it. Everything else builds on this one idea. The data, real data. 4 students. Student A, 1 hour to 40 marks. Student B, 2 hours to 50 marks. Student C, 3 hours to 60 marks. Student D, 4 hours to 70 marks. See the pattern? As study hours go up, scores go up too. Regression draws a line through this data, not by guessing, calculated mathematically to be as close as possible to all points. This is the regression line. It shows the exact relationship. 3 patterns. Not all relationships are the same. 3 patterns. Positive. As X increases, Y increases. More study, higher score. Line slopes up. Negative. As X increases, Y decreases. Higher price, lower demand. Line slopes down. No relationship. X changes, Y doesn't respond. Random scatter, flat line. Example, shoe size and exam score. Your shoe size tells us nothing about your marks. First question in any regression. Which direction? Up, down, or nowhere? The equation. The regression line is written simply. Y equals A plus B times X. Y equals what we explain. The exam score. X equals what affects Y. Study hours. A equals the intercept. Y when X is 0, the starting point. B equals the slope. The most important number. How much Y changes when X goes up by 1 unit. B is the effect. A is the starting point. Together, the full picture. What B really means, real example. Score equals 30 plus 10 times study hours. A equals 30. A student with 0 study hours scores 30. The baseline. B equals 10. Every extra hour adds exactly 10 points. On average, one number turned studying probably helps into studying helps by exactly 10 points per hour. That's the power of regression. Predict. 1 hour to 40, 2 hours to 50, 3 hours to 60. Clean and precise. Why we need regression. Why not just guess? Because real life is messy. Exam scores depend on study hours, sleep, intelligence, attendance, motivation, all at once. Compare high and low scores, and you can't tell which factor matters. Regression isolates one factor while holding others constant. In economics, we call this ceteris paribus. All else equal. If everything else stays the same, what is the pure effect of one more study hour? Only regression can answer this. Correlation is not causation. Important warning. A strong relationship doesn't mean X causes Y. Ice cream sales and drowning deaths both rise in summer. Correlated? Yes. Causal? No. Both are caused by hot weather. Hot weather leads to more ice cream. Hot weather leads to more swimming, leads to more drowning. Always ask, is there real causation? Or are both variables responding to something else? We explore this fully in the next video. Summary, let's recap. 1. Regression measures the relationship between x and y. 2. 3 types: positive, negative, no relationship. 3. Equation is y equals a plus bx. 4. A is the intercept. B is the slope, the key number. 5. Regression isolates one effect while holding everything else constant. Check your understanding. Now a question for you. Pause and think. A regression shows exam score equals 30 plus 10 times study hours. If a student studies 2 hours, what is the predicted score? And what does 10 represent? Answer. Predicted score, 50, because 30 plus 10 times 2 equals 50. The number 10 is B, the slope. Each extra hour adds 10 points, on average. Got it right? Congratulations. You understand the core of regression.